Okay, so we're going to help Myra calculate how tall the sand cliffs are just by using our knowledge of similar triangles and a few numbers. Now this is not an exact scale picture, this is just a very rough picture just to give you an idea of how to calculate. So we have Myra, who's going to be using a tree that is approximately 3 meters above her eye level. Okay, so we can see this little tree kind of in this area here. We'll call this the tree. We're going to pretend that that tree goes right down to the ground, and we're going to say that that tree is approximately 3 meters above her eye level. Now if that tree was to be planted in the ground here, she has measured, she's approximately 15 meters away from the tree that she is going to be using as a guide or a reference. And she has calculated or estimated that from her to the sand cliff face is 315 meters. So she measured from the tree to the face of the sand cliff was 300 meters, but then she added the 50 meters that she is standing away from the actual tree. So once we kind of know how she's been set up, we can use our knowledge of similar triangles to make some calculations. So what we're going to do is try and find the height of the sand cliffs, and we're going to just label it X. That's going to be our unknown. Okay, so the first thing we want to do is make sure that these are similar triangles, and what we know from previous lessons is that if two triangles share at least two out of the three angles are congruent or the same, then they are going to be similar. So these both have right triangles, and they both share this angle. So they both have congruent right angles and an acute angle. So they have two out of their three angles are congruent, so they are similar triangles. Alright, one more way to figure it out is, since this is a right triangle, or these are right triangles, if we know the properties and characteristics of right triangles, we know that if the two triangles share at least one congruent corresponding angle, which is this guy right here, then they will also be similar triangles. So we now know that these are similar triangles, and we can just do some quick calculations to get our unknown. Okay, so we know that the smaller triangle is, we look at the bottom side is 15 meters, and if we compare that to the corresponding triangle, or the corresponding side on the other triangle, it's going to be 315 meters. Now the way I got that is I took the 300 meters from her tree to the cliff face, plus you also have to add the distance between the tree and where she's standing, which is 15. So 300 plus 15 is 315. So if that's the case, then we take the larger triangle, and we know that our known side on the smaller one is 3 meters. But if we look at the corresponding side on the larger triangle, that's our unknown. That's going to be X in meters. So we just simply do some cross multiplication now. So 15 meters times X meters is going to be 15X. 315 times 3 is going to be 945 meters. Now we want to isolate X, so we're going to divide by 15. Divide both sides by 15. That's going to isolate X, and 945 divided by 15 is 63. And we carry our units, which is meters. So we have calculated approximately the height of the sand cliffs, which are 63 meters. Now, this does not mean that the actual cliffs are 63 meters in real life. This is just an example of a way to calculate the height of something that is too large to do it manually.